Good afternoon, everyone. Completed the example that I have given for homework.
Ma'am, you didn't give any example.
Seriously, wait, I think I have given some examples. Huh?
No, ma'am.
Okay, I think it was 2xt minus 4x square. You have solved it now. Lambda equal to minus 3 was the answer.
Yes, ma'am.
Yes, everyone got the same answer. आहेत का बाकीचे?
Yes, ma'am.
Let us go for the next example. Y of x is equals to f of x plus lambda integration 0 to 1 xt y of t dt. So this is the example for the non-homogeneous case. Okay, since f of x is given to us. Okay, so what you have to do, we have to follow the same process that we have done for the method. Okay, start writing with me only, and then we'll solve this example. Okay, f of x plus lambda, the terms of x will take outside the integration. Inside the integration, we'll have only the terms with t, y of t dt. Okay, so here we have y of x is equals to f of x plus lambda x. The value of this whole integration, we can put it as some constant c. Let me name this as equation 1. This is what 2 and c equal to. What is the value of c? Integration 0 to 1 ty of t. This is what your equation number 3. Correct? Okay. What you have to do? You have to put the value of y of t from your equation 2 so that we can find out the value of a c. Okay. So here we can put it as f of t plus lambda t into c. Integration is here with respect to t. Okay. Written after this.
Yes, ma'am. Ma'am.
Okay, what you can do now? C is equals to integration 0 to 1 t f of t dt. We cannot apply the integration, or we cannot solve the integration for this one because f of t is not known to us. Simply f of x is a function given to us, so this we will keep as it is. And here we have lambda and c outside the integration. Those are constant p square dt. Okay. So this will be integration 0 to 1 t f of t dt plus lambda c. Integration of t square will be t cube upon 3 within the limits 0 to 1. Right? C is equals to integration 0 to 1 t f of t dt plus lambda c upon 3. Correct? And t cube within the limit 1 to 0, it will be nothing but 1 minus 0. So hence we can get the value of this integration will be like this. Now let me find out what will be the value of c. If I take c common, what will be the resultant? 1 minus lambda upon 3 is equals to integration 0 to 1 t f of t dt. Okay. So hence we can write now c is equals to integration 0 to 1 t f of t dt divided by 1 minus lambda upon 3. Okay. So in this way we got the value of a c. Now let me name this as say equation 4. Now we can substitute this equation number 4 in 2. Okay. Using equation 4 in equation number 2. What is your equation 2? F of x plus lambda x into c. F of x plus lambda into x into c. Okay, so this is what an answer of our integral equation. Okay, what we have done a very simple calculation. We are provided with this equation, apply the method. What we have to do, first take the terms of x outside. Whatever we have inside the integration, we can name this as a constant because upper limit and lower limit are some numbers, that is some constant numbers are given to us. Okay, after that what we have to do, we have to write down the equation for c, and in that equation of c we have to put up the value of y of t by using our equation 2, and hence after using very simple steps of integration we get the value of c. This value of c you have to put in our equation 2 and hence the result. Okay, now can anyone tell me for which value of a lambda this equation fails? Hello?
Lambda equals to 3, ma'am.
Okay. Why for lambda equal to 3?
Denominator becomes 0.
Okay. If denominator becomes 0, what will happen? It is 1 upon 0 will be infinity. So here you can say this result is true for lambda not equal to 3. Or we can say the result is true for r, that is real line minus. It means we are going to just remove our point 3 from our domain. Okay, so hence we can say the result is true for lambda not equal to 3. Okay, and is a solution of our given integral equation. Okay, lambda can take any value, but it should not take a value 3. Okay, let us go for next example. खूप fast होते का?
No, ma'am.
If it is not, let me go for the next example. Y of x is equals to cos x plus lambda integration 0 to pi sin x y of t dt. Y of x is equals to cos x plus lambda integration 0 to 1, integration 0 to pi sin x y of t dt. Okay, try to solve this and tell me the answer just now.
Ma'am,
Hmm?
ma'am, we are not getting the value of c, but we are getting value of lambda as half.
Correct. Lambda equal to half. Hmm. Okay, let me solve this. What we can do is y of x is equals to cos x plus lambda sin x integration 0 to pi y of t dt. Okay, so here we can write y of x is equals to cos x plus lambda sin x into c. So this is what your equation 2 and the given equation is 1. And what is the value of c? Integration 0 to pi y of t dt. Now let us put up the value of y of t. So that will be cos t plus lambda sin t into c. So what is the integration of cos is sin t plus lambda as it is, integration of sin is minus cos t. Okay, within the limits, so here c is there, 0 to pi. Okay, sin n pi is 0, sin 0 is 0, so this term will be 0. So we have it is lambda into c, negative sign. Next it is cos pi minus cos 0. What is the value of cos pi?
-1.
Correct. So it is nothing but 2 times lambda into c. So hence now we can take c outside. We can have it is 1 minus 2 lambda if I take a c common. Okay. So the product of these two is equal to 0 means one of them should be equal to 0. And if I want to find out the value of a lambda from this equation, so what should be the 0? If c is 0, then only, if c is not equal to 0, then only what will be the next term? 1 minus 2 lambda equal to 0. Okay, either of them should be 0 if product of these two is 0. Next, if c equal to 0, this 1 minus 2 lambda will not be equal to 0. So if we consider this case, we will get value of lambda is a 1 by 2. Correct? So
Yes,
there are
ma'am.
two, either 1 minus 2 lambda equal to 0, that means either we get lambda equal to half, or another case is c equal to 0. If I get c equal to 0, what will be the resultant? If I put value of c equal to 0 in equation 2, we get the solution is cos x. Correct? After putting in this equation, let me write down this equation, cos x plus lambda sin x into c. Okay. In this equation, if I put c equal to 0, we get the result is y of x is equals to cos x. Or in another way, I can put the value of lambda is a half and c is a non-zero. We get the corresponding function as plus lambda is 1 by 2 sin x and some constant c. And as we have assumed that this c is non-zero, in the second case, for c non-zero, we are getting lambda is half. Correct? In this case, we are getting c is non-zero and lambda equal to half. So this c by 2, I can write it as some, we can say this c by 2 is equals to 1, and hence we get the solution is equals to cos x plus sin x when lambda is 1 by 2. Okay. Are you getting how to solve the examples? यहाँ पे
Yes, ma'am.
Yes, ma'am.
इक्वेशन वगैरह कुछ नहीं है. Simply, why we are going to study this integral equation? Actually, this is what a base for your fractional integration. Okay. I hope you come across the things like say dn by dx raised to n of a function f of x. Correct? Now, can anyone tell me what is a value of n here? What should be the domain, or where should we restrict the value of n? Or is there any restriction, or there is no restriction for value of n?
Ma'am, until that function becomes a constant.
No, no, I am not restricting about f of x. f of x एक ऐसा फंक्शन है जिसका infinitely many times differentiable है, just like your sin x.
Ma'am, in that case, n is a positive integer.
It should be positive.
Positive integer.
Okay, positive integers means what? It should be either say 1, 2, 3, and so on, like this. No? It may be 0 also if I want to take. What will happen if it is minus 1? विसरलं सगळं. D raised to minus 1, D raised to minus 2. Okay. हे पण आठवत नसेल तर 1 upon D हे तर आठवला का?
Integration.
करत होतो ना BSc, I think second year somewhere. Something like this type of example we have solved. Say it is D minus 1 square, or it may be 1 upon D minus 2. Suppose
Yes,
here
ma'am.
to AX is there, then we are going to substitute A here. These type of examples we have solved. So if it is 1 upon D, so it will be integration. That means for 0, it will be simply, we are not going to differentiate. If it is 1, 2, 3, and so on, so we are going to differentiate that number of times. If it is minus 1, minus 2, minus 3, and so on, so this will be nothing but your integration, and this is derivative. Now, can anyone tell me if it is going to take the value in between 1 and 2? Suppose it is 0.5. What will be the result? Is there any existence of such a things?
Yes, ma'am. Fractional derivative.
I think Shivani knowing about this one. Can anyone answer this question? Except Shivani, because we have already done a discussion. Anyone else? Just try to think on this one. D raised to n by dx raised to n of any function f of x. For n, we have the values of n we have discussed for minus. That means we have discussed for any integers. If it is positive, we can differentiate. If it is negative, it will be integration. But what about for n equal to 0.5?
Ma'am, we can take 0.5 as 5 by 10.
0.5 as?
5 by 10.
Okay, then what will happen if you take 5 by 10? Can you find out the derivative for this? That means d raised to 5 by 10 divided by dx raised to 5 by 10.
We can take that 1 raised to 10 outside. First, d raised to 5, then raised to 110.
Acha, in this way you are going to solve. Okay, for this it is okay, na? You can take 1 upon 10 outside, no doubt. But actually, this is wrong process. What you are saying is 1 upon 10 outside, and because if you want to find out the derivative, you have to find out directly. Okay, so you can do by this. But if suppose I am saying n is equals to root 3, then how you will find out the derivative? बाकीचे पण बोला, चौथं सेमिस्टर आहे, याच्यानंतर आम्ही विचारणार नाही, तुम्ही आम्हाला विचारणार नाही, कुठे भेटले तरी पण ओळखणार का नाही माहित नाही. Yes, can anyone answer this? Can you find out a derivative with n equal to root 3?
Ma'am, you tell.
Okay. that, let us go back whatever the things we have studied initially in the derivative. Derivative का starting में क्या सीखा था आपने? First principle. Say f dash of c is there. So limit as h tends to 0.
Ma'am, nth derivative काढल्यावर
Nth derivative?
if we calculate nth derivative, then we can put n is equal to √3. no?
Root 3. Okay. Then that is what a question ना, n की जगह पे ही हमको √3 रखना है. सपोज आपके पास फंक्शन एक sin x है, correct? Sin x, tan x, cot x, in any type of a function. So how will you say that what will be the root n equal to √3 the derivative of a sin x? That is what our discussion now, whether n can take any real number or any complex number values. Whether n can take any real or complex values. n तो फाइंड आउट करना है ना, n इक्वल टू √3 के लिए रिजल्ट ट्रू है या नहीं.
Yes.
Okay, so here we have f of x plus h minus f of x divided by h, correct? This result we have already studied. Now if I want to find out the result for t raised to half, that means if I want to find out a half derivative, how you are going to find out this half derivative? Suppose we will go for very simpler one, na? That is for these numbers we have the derivative. But what about the derivative in between 0 and 1 and 1 and 2? That means it may be 1.5 or 0.5. Okay, what will happen for n equal to half? Okay, let me write down this. What is the derivative of x raised to n?
nx raised to n minus 1.
Correct. Now here there is no restriction on this n. Now it can be any number. But if I want to find out a half derivative of this, how you will find out a half derivative of this? This is simply first derivative, na? Nx raised to n minus 1. This is about a first derivative. What about half derivative, 1/3 derivative and all? Okay. See, we'll have a discussion on this later on in the next lecture, but I will give you a hint for this. This is what origin of fractional derivative. Or we can say it is for fractional integration also. We can have the same term for fractional integration. That means it may be with negative numbers. यहाँ पे हमने डिस्कस किया था ना, ये निगेटिव रहा तो इंटीग्रेशन आएगा. अगर इन दोनों के बीच में कोई वैल्यू है तो वो निगेटिव, दैट मीन्स इट विल बी फ्रैक्शनल इंटीग्रेशन. ओके, एक्चुअली हमने जब वो इक्वेशन लिखा था, राइट, डी raised to n by dx raised to n of f of x, this was given by Leibniz. Leibniz rule for integration derivative we have studied. Actually, Leibniz has written this for dn by dx raised to n of f of x, correct? But at that time उसने ये नहीं बोला था कि ये n पे कोई रिस्ट्रिक्शन है. ये रिस्ट्रिक्शन हमने दिया है ना, हम सिर्फ n इक्वल टू इंटीजर्स के लिए सॉल्व करते हैं, राइट? हम मतलब स्टूडेंट लेवल, बट in the level of research it can take any value in between 0 and 1 also, right? So we have restricted this for integer, but actually when Leibniz started the derivative उसने कोई restriction नहीं रखा था n पे. N can take any value, rather it may be real or complex number. Okay, so if n can take any value, rather it is real or complex number. Complex का मुझे भी उतना idea नहीं है, but it can take any value, that is it may be any real number. Okay, So actually, fractional calculus was initiated here with the Leibniz. He has not given any condition on n, correct? And here, actually, the fractional का हम जो study करते हैं first derivative. Suppose we go for a first derivative of any function, it will give you a slope of a tangent, and rather we can say it is giving you a rate of change. Second derivative will give you a rate of change of a slope of a tangent. Okay, and so on. Or rather, we can say first derivative is a velocity, and for second derivative is acceleration. And now here, what will happen if I am going to take a half derivative? What is a geometric interpretation behind the half derivative? मुझे भी एक्चुअली इसका आंसर पता नहीं है कि हाफ डेरिवेटिव का ज्योमेट्रिक इंटरप्रिटेशन क्या है, करेक्ट? So actually this whatever this term we are writing here, this n is true for any real number, and hence there is introduction of a fractional derivative and fractional integration, or rather there is a fractional integro differential equation. What do you mean by integro differential equation? That means it contains terms of integration as well as a derivative. Okay. So what was your homework? You have to find out what will be the half derivative of this one, or half derivative of any function. If you want to evaluate, you can evaluate. In the next lecture, definitely I am going to tell you what is a theoretical way to find out a half derivative. Since I am not knowing exactly what is a geometric interpretation behind the half derivative, or rather what is a geometric interpretation in between 0 and 1, right? Rather in between 1 and 2 or not. What is a geometric interpretation for any real number? Because we know about the first derivative, second derivative, and so on. So here, what was our discussion? क्योंकि हम यहाँ पे इंटीग्रल इक्वेशन में क्या कर रहे हैं, सिर्फ एक मेथड है, right? After the method, we are going to solve the examples. So actually, there is no geometric interpretations also now. Since no doubt we can find out what is your solution. Okay, यहाँ पे क्या है solution आपका y of x is equal to cos x. So you can find out the geometric interpretation of cos x and cos x plus sin x and all. Okay, but what is the use of this integral equation paper is, आप जब अगर फ्रैक्शनल इंटीग्रल इक्वेशन या फ्रैक्शनल में कुछ रिसर्च करना चाहोगे तो वहां पे ये इंटीग्रल इक्वेशंस के सभी मेथड्स आपको अप्लाई करने पड़ेंगे, राइट? सपोज I think we have done this in the differential equation paper. We have applied initial value problem, boundary value problem. The same initial value problems, boundary value problem are applied to fractional. Okay, and fractional is not so much easy because अगर आप initial value problem में अगर constant C1 C2 के values निकालना चाहते तो बहुत easily निकल जाते ना. It is not so much difficult to find out the values of those constants, but in fraction it is somewhat difficult to find out the values of those constant terms. Okay, in the differential equation we have studied IVP, BVP, so those things which we have studied in our BSc or MSc, these things in the research we have to apply for a fractional integral differential equations or fractional integral equation, and we can apply for fractional differential equation. So there are many type of differential equations are there. The first I don't know exactly the name. Riemann-Liouville. उसने इंट्रोड्यूस किया है फ्रैक्शनल को, रादर उसने एक डेफिनेशन दिया है फ्रैक्शनल का कि फ्रैक्शनल के डेरिवेटिव कैसे निकाल सकते हो. देर आर सो मेनी एक्चुअली डेफिनेशंस ऑफ फ्रैक्शनल डिफरेंशियल इक्वेशन. रीमन-ल्यूवले ने किया है, बहुत सारे डिफरेंट मैथमेटिशियंस ने भी डिफाइन किया है कि फ्रैक्शनल डेरिवेटिव को कैसे सॉल्व करें या उसका डेफिनेशन क्या है. जस्ट लाइक अवर डेफिनेशन ऑफ अवर first principle, that is limit as h tends to 0 f of x plus h minus f of x divided by h. So in this way they have defined what is a fractional differential equation. Okay, let me share the screen if I have that PDF. अगर मेरे पास रहा तो मैं शेयर करती हूँ, 1 मिनट.
Ma'am,
Yes.
in future, then the students will also study fractional derivative in the syllabus.
होप सो, बट इतना इजी नहीं है ना, वो थोड़ा मतलब इंट्रोडक्शन आ सकता है, just like what is a definition, how the Riemann-Liouville has defined, what is some small छोटे छोटे जो सम्स रहते हैं ना उसका आ सकता है, बट आई डोंट नो एग्जैक्टली कितना सिलेबस में होगा. वेट फॉर 5 मिनट्स. हाँ, ये ओपन होते ही मैं आपको दिखाती हूँ. Is the screen visible?
Yes, ma'am.
So यहाँ पे लिखा है देखो. Okay. Fractional calculus is an extension of ordinary calculus. You can see here more than 300 years of history is there for this one, because हम जो पढ़ रहे हैं वो तो बहुत पुराना है और ये fractional तो 300 साल पहले introduce किया है. Fractional calculus was introduced by Leibniz and L-Hospital. वहाँ पे जो ये जो वैल्यू लिखा था ना उसने dn by dx raised to n. So actually L-Hospital ने हमने L-Hospital रूल यूज किया है ना 12th में. L-Hospital ने एक लेटर लिखा था Leibniz को that whether the result is true for n equal to half. Due to that letter itself, the fractional integration or fractional derivative has been arrived. So you can see L-Hospital wrote a letter to Leibniz asking him about the particular notation he has used in the publication for nth derivative, and also L-Hospital asked a question that whether the result is true for n equal to half. Okay. And later on, many research has been done in this Leibniz in this fractional derivative. Okay. Let me show you that definition, Riemann-Liouville fractional derivative. Okay, are you able to see this screen? Is there a screen?
Yes, ma'am.
Okay, so you can see here, this d raised to minus alpha ax f of x. I will explain what are these notations and all. Okay, so I think Shivani is knowing about this now. Have you studied Riemann-Liouville fractional derivative?
Yes, ma'am.
Okay. Sorry for interface because you were knowing, so that's why I haven't asked you. So here you can see here that d raised to minus alpha f of x, and this they have written it as dn by dx raised to n. So this n, and here we have this 1 upon gamma n minus alpha d by dx raised to n and all. Okay, ये क्या है, सिर्फ उसने ऐसे डिफाइन किया है कि फ्रैक्शनल डेरिवेटिव को हम ऐसे लिख सकते हैं. ओके, अब यहाँ पे जो अल्फा उसने लिया है उसका एक इंटरवल दिया है, अल्फा लाइज इन बिटवीन n-1 to n, where n is the smallest integer greater than alpha. Okay, so alpha is any number, and alpha which is lying in between n-1 and n is the smallest integer greater than alpha. So we can take some value of alpha, and depending on you can select the interval. The fractional derivative of order of alpha for f of x, ये अल्फा उसका ऑर्डर है फ्रैक्शनल डेरिवेटिव. ओके, सो आप स्टडी कर सकते हो अगर करना चाहते हो। रिमन लिवले फ्रैक्शनल इंटीग्रेशन, अगर इंटीग्रेशन लेना है तो ऐसे आएगा। और ये क्या है, कैपिचो ने अलग से डिफाइन किया है, उसने इंटीग्रेशन सॉरी डेरिवेटिव है 1 upon gamma of n minus alpha अंडर द इंटीग्रेशन a to x। ये जो a to x आपको दिख रहा है ना यहाँ पे, suffix of d, a and x, these are just showing that the limits of integrations are a to x. This minus alpha is there. Alpha is what, the order of our integration, और उसको उसने ऐसे लिखा है dn and d by d raised to n by dx raised to n, and then finally value of this term we have written here. Okay, this is simply x minus t raised to n minus alpha minus 1। जो हमने मल्टीपल इंटीग्रेशन को सिंगल इंटीग्रेशन में कन्वर्ट किया था ना, उसके जैसे ही है ये, बट नॉट एग्जैक्टली सेम। वी कैन जस्ट हैव अ रिजेम्बलेंस। सो ये डी बाई डी एक्स रेज टू एन को आउटसाइड रखा है, ये इंटीग्रेशन सॉल्व करके 1 upon गामा एन माइनस अल्फा यूज किया है। एक्चुअली आपको अगर ये डेफिनेशन को अंडरस्टैंड करना है तो आपको गामा और बीटा फंक्शंस का यूज फ्रैक्शनल में क्या है वो अगर आप पढ़ोगे तो ये 1/n माइनस अल्फा क्यों आया है आपको समझ में आएगा। ओके, जस्ट लाइक अवर डेरिवेटिव n x रेज टू n माइनस 1, उसके जैसे ही ये n माइनस अल्फा को 1 upon गामा n माइनस अल्फा की तरह लिखा है। ओके, हम डेरिवेटिव कैसे लिखते हैं, n डेरिवेटिव ऑफ x रेज टू n इज n x रेज टू n माइनस 1, और यहाँ पे उन्होंने ये जो है टर्म उसको 1 upon गामा n माइनस अल्फा में लिखा है, और रेज टू n माइनस अल्फा माइनस 1, द फंक्शन इज केप्ट एज इट इज। ओके, यहाँ पे भी वही उसी तरह डिफाइन किया है, थोड़ा बहुत डिफरेंस है सभी के डेफिनेशंस में, और बहुत सारे डेफिनेशन है, ये सिंपल 300-400 साल पहले के डेफिनेशंस है फ्रैक्शनल के। इसके आगे भी बहुत सारा इंट्रोडक्शन हुआ है। आप जैन मैडम को पहचानते होंगे ना सब लोग, जैन मैडम फ्रॉम नांदेड़ यूनिवर्सिटी, उनका ज्यादातर रिसर्च इसी में है। यहाँ पे भी है देखो, this is about alpha beta, that means it can have 2 orders, alpha into beta. The many research has been done in our fractional.
Ma'am, then which one of these is universally accepted?
Which
one amongst these is universally accepted?
आप क्या बोल रहे, थोड़ा आवाज कट के आ रहा है, आप थोड़ा हेडफोन यूज करके बोलिए। Which universal?
Ma'am, which one of these is universally accepted?
यूनिवर्सली एक्सेप्टेड, सभी डेफिनेशंस को एक्सेप्ट किया है, बट क्या बोलते हैं उसको, अभी हमारा जो फर्स्ट डेरिवेटिव डेफिनेशन है वो तो यूनिवर्सली एक्सेप्टेड है ना, लिमिट एज h टेंड्स टू 0 f of x plus h minus f of x divided by h, वो सबको पता है। बट मुझे भी इतना कुछ आइडिया नहीं है कि फ्रैक्शनल को एग्जैक्टली कैसे किया। मेरा एक्चुअली इंटरेस्ट था कि डी हाफ का फ्रैक्शन ज्योमेट्रिक इंटरप्रिटेशन क्या होगा, बट अनफॉर्चुनेटली आई वाज नॉट एबल टू डन अ रिसर्च इन दैट, क्योंकि मेरे जो गाइड है उनका रिसर्च एरिया डिफरेंट है। अगर मैं उसमें पीएचडी कर रही होती तो शायद इन डिटेल आपको समझा सकते थे कि इसको ऐसे ही क्यों लिखा है। सभी के डेफिनेशंस को एक्सेप्ट किया है क्योंकि उन्होंने कुछ रिजल्ट भी दिया होगा ना कि व्हाई दे हैव रिटन दिस लाइक दिस, डेरिवेटिव का डेफिनेशन सभी फ्रैक्शनल में। यहाँ पे भी है कुछ डेरिवेटिव, यहाँ पे भी रिमन लिवले का ही डिफाइन किया उन्होंने। ये इंटीग्रेशन है, आई रेज टू क्यू मीन्स इट इज ऑफ ऑर्डर क्यू and it is written as 1 upon gamma q 0 to t, this function 1 upon t minus s, just like t minus x। यहाँ पे किसने डिफाइन किया, n टाइम्स डिफरेंशिएबल फंक्शन कैपिटल डेरिवेटिव, n टाइम्स रहा तो गामा n माइनस क्यू लिखते हैं। मैं सिर्फ आपको इसलिए दिखा रही हूँ कि अपना इंटीग्रल इक्वेशन हम क्यों पढ़ रहे हैं। ओके, यहाँ पे हमने देखा होगा इन मल्टीपल इंटीग्रेशन कन्वर्टेड टू सिंगल इंटीग्रेशन में हम t माइनस एक्स लिखते हैं ना। डेफिनेशंस एक्चुअली ये जो आपका फ्रैक्शनल है, फ्रैक्शनल में मोस्टली बनार्क स्पेसेस बहुत यूज होते हैं। बनार्क स्पेस ऑफ कंटिन्यूअस फंक्शन, फिर सभी ये जो नोटेशंस है ना, सी कैपेचो डेरिवेटिव का वगैरह, बहुत सारा बनार्क स्पेस का भी यूज है, और हिल्बर्ट स्पेस है, कॉम्पैक्ट स्पेस, कनेक्टेड स्पेस, फिर डेरिवेटिव है। डेरिवेटिव में भी वो साहिल डेरिवेटिव, बहुत सारे डिफरेंट टाइप्स है। यहाँ पे भी आप देख सकते हो कॉम्पैक्ट मैपिंग, कॉम्पैक्ट मैपिंग, कनेक्टेड स्पेस, बहुत सारे स्पेसेस का भी यूज हुआ है इसमें। मुझे उतना एग्जैक्ट आइडिया पता नहीं है, अगर मेरा रिसर्च उसमें होता तो मैं इन डीप बता सकते थे आपको। So that's why I just discussing you about that, why we use or why we have a paper of integral equation। क्योंकि पेपर में क्या है, सिर्फ मेथड एग्जांपल्स है ना, इसका कोई ज्योमेट्रिक इंटरप्रिटेशन या कुछ थ्योरी नहीं है। जस्ट लाइक अ डीप स्टडी ऑफ अलजेब्रा 2 और अलजेब्रा 1 MI जैसे आप पढ़ते हो, इसका एक्चुअली यूज आपको आगे होगा अगर कोई रिसर्च करना चाहते हैं। सो जो भी मेथड हम यहाँ पे पढ़ रहे हैं इंटीग्रेशन के, जस्ट लाइक derivative inside the integration, the Leibniz rule we have studied for that, and multiple integration converted to single, and those IVP, and how to apply the direct integration for any differential equation. Up to now, we have the things like, say, if you are having any differential equation, what we can do is simply we are going to find out the roots and we are going to write the solution. But in this integral equation paper, we have studied how to find out the derivative, how to find out the solution of any differential equation directly, right? We have converted the any differential equation to IVP, and then sorry, any initial value problem we have converted to Volterra integral equation, and boundary value problem we have converted to फ्रेडोल इंटीग्रल इक्वेशन। ये जो है ना वोल्टेरा और फ्रेडोल इंटीग्रल इक्वेशंस, इन सब का यूज आगे आपका फ्रैक्शनल्स में होगा। फ्रैक्शनल वोल्टेरा इंटीग्रल इक्वेशन, फ्रैक्शनल फ्रेडोल इंटीग्रल इक्वेशन, उसके बाद हम ग्रीन्स फंक्शन स्टडी करेंगे। हिल्बर्ट स्मिथ थ्योरम इज आल्सो देयर। So these are the things whatever we are studying in the paper of integral equation is only a base for a fractional paper. I think in the syllabus of Nanded, they have kept one paper of fractional derivative. They are going to मुझे पता नहीं उन्होंने teach किया है या नहीं। मतलब syllabus में तो है, just like our syllabus, it is SAT 1.2, 1.3, वहाँ पे हो सकता है, बट एक्चुअल वो लोग रन करते हैं या नहीं पता नहीं। बट तो बहुत सारी यूनिवर्सिटीज ने फ्रैक्शनल को एक पेपर की तरह डिजाइन किया है, मतलब अपने सिलेबस में रखा है। एग्जैक्टली वो उसको पढ़ाते हैं पता नहीं। अभी भी हमारा भी सिलेबस रिफॉर्म ना, उसमें हम लोगों ने लेटेक्स को इंट्रोड्यूस किया है, लेटेक्स सॉफ्टवेयर। फर्स्ट ईयर स्टूडेंट नाउ दे आर नॉट डूइंग असाइनमेंट एंड हाउ टू राइट डाउन, simply they have to run the programs on latex and they have to show it and the assignment will be done. Okay, and then next we are going to introduce Scilab for them. So this is what fractional we have. Okay, let us go for the next example. हम क्या डिस्कस करेंगे? Let's go for next example. Let me write down this. Phi of x is equals to x plus lambda integration 0 to 1 x t square plus x square t y of t dt. Okay, so now we have to solve this example in such a way that now we get the values of c1 and c2. Okay, Start solving with me. Lambda x integration 0 to 1 e square y of t dt plus lambda x square integration 0 to 1.
Ma'am, screen is not visible.
Yes, ma'am.
Okay, let me.
eating soda.